Hello, everyone. Welcome to the world of mathematics. I am an IITian myself and have been teaching mathematics from over 10 years now and have created many IITians in this journey. After igniting mathematical curiosity offline, I now want to reach out countless aspiring students through these digital platforms. Let us start unlocking the secrets of mathematics together now. So, in today's topic, I'm going to start with calculus. Now, calculus itself is a pretty vast topic in itself, and students do fear from calculus quite a lot. So, I thought of starting the topics from calculus itself. So, let's start our journey. So, what is calculus? Calculus is the branch of mathematics which relates engineering with science. So, basically, a lot of things, etc., which you have learned in your physics, chemistry, engineering, etc., or which you will be doing a lot of things, etc., in your engineering courses would be dependent on calculus. Your civil engineering, aerospace engineering, electrical engineering, computer science, robotics, a lot of these are dependent on differential equations, differential calculus, integral calculus, and so on, right? You must have, I don't know whether you guys know it or not, economics use a lot of differential equations. In defense, in biology, how the growth of microorganisms, etc., go on and so on. So, biology, a lot less use of calculus though, but calculus is like everywhere. And probably you must be already using a lot of calculus in your physics already. Best would be that when you understand the basics of calculus from here itself, then the earlier you know, better it would be for your physics understanding as well. So calculus has immense applications and use. So let's begin this journey together. What do you need to know? It's a vast topic and rely on many branches of mathematics actually. Okay, and but very important topics which you should already know in some manner is algebra, trigonometry, and geometry. Now, but what will happen if you don't know these topics, right? It's completely okay. What I will do is I'll try to make you understand these concepts of calculus in a very lucid manner, from very basics to very advanced level altogether. So don't worry about it if you don't know these topics already. It's good if you know these topics already, but if you don't know these, we will cover up these topics also in other videos. But in understanding of calculus, I'll cover up these sections also uh, in a phased manner. Now, what you'll learn in this course is this complete list of topics, the sets, inequalities, functions, graphs, limits, continuity, differentiability, application of it, integration, differential equations, and a lot more things. After this course, you would be able to apply a lot of differential calculus or integral calculus methods in your physical life. You would be able to utilize the things, etc., which are available to you. So it has a lot of industrial applications, so you will be able to utilize these limited resources in a very fruitful manner. So that is how it is. But I'm going to start this journey with very basic concepts, and I'll start with basics of sets. So the entire calculus starts from the number system. So I'll quickly try to cover this up. So the number system starts with natural numbers. So it's all started with the counting principles altogether. Earlier, people were not able to count the numbers, but eventually, and what they used to do is when they used to keep the sheep, etc., they used to keep designated spaces in the barns and used to fill in those barns. And when some of the barns are left out, they completely used to know that okay, the sheep is not available and I have to go for searching and that those particular sheep to actually fill up the barn. There was no concept of numbers at all, but eventually humans understood the concept of numbers, etc., and came up with natural numbers which comes naturally to us. And this started the beginning of counting: 1, 2, 3, and 4, and so on, and it goes till infinity. But of course, they started with smaller numbers as such. Then came the concept of whole numbers. So it took a while for humans to actually understand the concept of zero or nothing, and so it came a little while later. but we eventually understood the whole number. So whole numbers are nothing but natural numbers, but including zero, right? So that those are whole numbers. Integers, now with understanding of the numbers, and eventually, and this is a lot recent concept altogether, the concept of integers, we started talking about the negative numbers as well, right? So from -3, -2, -1, -10, -20, those kind of numbers, etc., also started appearing, and we started talking about those numbers. So all negative numbers, all positive numbers, and zero is are all are going to form the set of integers. Positive integers is 1, 2, 3, 4, and so on. It is same as set of natural numbers. It is represented by z plus. Now it is very important that 0 is not included in this set. So 0 is not included in this set. If we want to include 0, I'll write it as z plus union 0. So that's very important. Z plus does not include 0 in it. Why I'm stressing on these definitions, etc.? Because we are going to use these kind of sets, etc., at a later stage, and we should not be confused at all while using these sets. Z minus are set of all negative integers. Of course, 0 is not included here as well. So if you want to include 0, you have to write Z plus Z minus union 0. Okay. Set of rational numbers, the set of all numbers which can be expressed in the p by q form. So set of all numbers which can be written in the fractional form are the set of rational numbers. Of course, the denominator cannot come out to be equal to 0, so that is important, and they should be in the reduced form. So HCF of p and q should come out to be equal to 1. So rather than writing 4 by 10, it's preferred to actually write it as 2 by 5. It should be in the reduced form so that p and q cannot be further cancelled out with some factors. So p and q, the HCF of it should come out to be equal to 1. Irrational numbers, the set of all numbers which cannot be expressed in the p by q form are the irrational numbers. So whatever is left out numbers are going to be set of irrational numbers. So in decimal form, we would say that these are non-terminating repeating decimal digits. So non-terminating, non-repeating decimal digits is the irrational. Non-repeating and non-terminating. Okay. Then comes the set of real numbers. The real numbers, the complete set of rational and irrational numbers will form the real numbers. Complex number is a topic in itself, and it's a lot new concept. And when I say about new, it all came in the last millennium. So complex numbers basically is the numbers which can be expressed in the form of x plus iy. So basically, these numbers were generated for making or solving the solution of x square plus 1 equal to 0. So this equation didn't had any solution altogether, and these numbers are formed for solving these such kind of equations as well. It's a topic in itself. It's a vast topic. We will not discuss this in very much in much detail right now, but it's a vast topic in itself, and we can cover up in the other videos. Prime numbers, and in this calculus we are going to talk more or less about real numbers for most of the time, so we need not to worry about complex numbers as such. Prime numbers are numbers which are divisible by 1 or by themselves, right? So 2, 3, 5, 7, 11, 13, and so on are all prime numbers. Very important that 1 is not considered as prime numbers. 1 is not considered as prime numbers, so please be very careful while taking up the prime numbers. I've given you this very basic concept altogether, that set of natural numbers is smaller than the set of integers. Set of integers is smaller than the set of rational numbers, is smaller than the set of real numbers, is smaller than the set of complex numbers. So this is a very important concept. We should understand this and use this whenever required. Now, set and intervals. So basically, set is a collection of things or objects or elements or anything you can think of. So basically, the collection of elements is called a set. Now, a set should be well defined. A well, if so, set of all human beings on the earth is a very well defined set. All human beings on earth is a very well defined set, but collection of all good boys in your class is not a well defined set, because the definition of good boys is not very well defined, because the concept of good is subjective and will depend on person to person, and hence it's not a well defined adjective, and hence it will not form a set. The set should be well defined. So it should be well defined, and each element in the set should be unique. Repetition of the element is disregarded. So basically, if you want to repeat an element, so set has A, B, B, okay, then the set is actually, we say that the set actually contains only two elements, A and B. These two sets are exactly same. The number of elements in this set and this set are exactly same. This set also has two elements. This set also has only two elements. So the repetition of the elements is disregarded. Generally, we use capital letters to identify the sets. So capital A, capital B, capital C represents a set, while if we want to write out the elements in the set, we write down in the curly brackets. So if we want to write individual elements in the set, we write it down in the curly brackets. So these are certain examples of the sets. Now a set can have finite number of elements or infinite number of elements. Like the set of natural numbers has infinite number of elements. 1, 2, 3, 4, and it goes up till infinity, right? So this has infinite number of elements, while a lot of sets, etc., will have finite number of elements as well, right? And some notations altogether, which could be pretty handy sometimes, would be like 1 belongs to set A. This is the set A. 1 belongs to set A. E belongs to set B. Gopal does not belong to set C. Okay, set C has Shyam and Radha. Gopal is not there in the set, so we write it as Gopal does not belong to set C. 0 does not belong to set of all natural numbers. So 0 does not belong to set of all natural numbers. 10 belongs to set of natural numbers. Number of elements in a set. This is called the cardinality of the set, and basically we can find out the number of elements in a particular set. For instance, the set B earlier has 3 elements. Set C had only 2 elements, Shyam and Radha, and set C has only 2 elements in the previous examples. We can also represent it as mod B, or cardinality of B, or the number of elements of B, or n of B as 3. Okay, so these are different ways of representing the cardinality or the number of elements in a set. If the number of elements in a set are infinite, we write cardinality is to be infinite. A null set. A null set is a set that is having no element. It is represented by curly brackets and nothing inside it. Okay, or as a Greek letter phi. Now we don't write this as this, so some people do make mistake like this. They write the null set as this. This is a wrong representation of null set. This is not the way we are going to write null sets. Null set has to be in the curly brackets without anything inside it. Okay, or it can be represented as phi. Clearly, if D is a null set, then the number of elements in D has to be equal to 0. So I have given certain examples here. So if there is repetition of elements, we will disregard those repetitions. Okay. There are 2 ways and the number of elements in this case is going to be 6. Okay. There are 2 ways in which we can represent the sets. Set can be represented in the roster form. Set can be represented in the set builder form. When we are explicitly writing each and every element of the set, right? Like say set A is equals to 1, 2, 3, or set B equals to 1, 4, 9, 16, 25, etc., and C is A, E, I, O, U, whatever it might be the case, if we are writing the terms explicitly, then we say it to be in the roster form. While if we are writing the elements not explicitly but in a concise manner altogether. So how to read this? Set A is X such that X belongs to natural numbers and X is between 0 and 4. Now X is a natural number between 0 and 4. That implies basically X will take the value 1, 2 and 3. So this set and this set is exactly same. Similarly, set B, even though we are going to write, or we can write infinite number of terms here, in a set builder form, it can be written in a very, very concise manner. Set B can be written as x squared such that x belongs to set of natural numbers. So x belongs to natural numbers, so x is 1, then the element would be 1 square, which is 1. X is 2, then it would be 2 square, which is 4. X is 3, which is a whole square is 9, and so on. Or set C. C is X such that X is vowel in English alphabets, right? So these represent the same thing altogether. One is written in the roster form and another one is written in the set builder form. I'm also going to quickly talk about the intervals. Okay, so continuous intervals. So whenever we want to represent a continuous interval, basically which is having all the points between the two given points, then it is called a continuous interval. How to represent A is less than X is less than B? There is a simple way. On the number line, we will write the open point A, open point B. Obviously, relative position of A and B should be very, very clear and correct on the number line. A is less than X is less than B, or it can be written as open brackets A comma B. In some of the books, etc., I've seen this kind of a notation also, hence I have mentioned this as well. This is not very regular notation altogether for to be used, but still I've just mentioned it so that if it comes in, then we should be very, very clear about how to use it. And clearly, if A is less than X is less than B, then I can write it as open interval A to B. That means basically all the points between A to B are included. All the points, all the decimal points, all the integer points, everything is included between A and B, but not A and B. A and B are not there. All the other points in between are there. Similarly, closed interval A to B. So the closed intervals are represented by dark points, and this represents A is less than equal to X is less than equal to B. And these are written in the closed brackets. So for this case, this is a semi-open, semi-closed interval, and I can write this as X belongs to closed interval A and open interval B. This means basically all the elements between A and B are included. A is also included, but B is not included. Similarly, this can be written as open interval A and closed interval B. So some important symbols altogether. This represents belongs to the reverse A. In a way, I can say it to be a reverse A. This represents for all values of. Okay, this symbol, a right arrow, implies the implies statement, and double arrow means if and only if condition. That means it is both sided implied. Okay, so the left hand side will imply the right hand side and right hand side will imply the left hand side. This statement represents the equivalent to, this symbol represents the equivalent to statement, and this represents does not belong to, as we have discussed earlier as well. Okay, so the very, very briefly summarizing everything with the brackets concept. Okay, or we say the concept of intervals or the brackets concept. And X belonging to 4 to 5 means 4 is less than equal to X is less than equal to 5. We have discussed all these things. Open interval at -5, that means basically -5 will not have an equal to sign here, while 20 is at a closed interval, so equal to sign would be included. Infinity, plus infinity or minus infinity is always open. The interval for bracket for infinity and minus infinity is always open. So x is less than 2 is open interval minus infinity to 2. Similarly, for other cases, x greater than equal to minus 23, equal to sign is there with minus 23. So close interval minus 23 and going up till infinity, and infinity will be always open bracket. X greater than 4, 4 to infinity directly. If x is going to take only two values, 4 and 6, if x is going to take only two values, either 4 or 6, then we represent it in the curly brackets, the way we used to represent the roster form. And if x is going to take all the real values, we can even write it as minus infinity to infinity, or I can write this as x belongs to R. So this was the concept of sets and the intervals. I hope you would have enjoyed. Thank you, and keep on watching these, and do like, comment, subscribe and share the videos. Thank you.